So you have to write in your class notes. If carbocation formed at beta position of naphthalene. Now what is the second RS? Then I will move this pi bond here. What is the meaning of cross? It can undergo resonance from left hand pi bond as well as resonance from, if carbocation formed at beta position of naphthalene, there will be a 7 RS. What is the case 1? In case 1, double bond conjugation with positive charge. So try to form new bond first. Don't try to break bond. What you have to do? You have to move lone pair then pi bond. In this example, this lone pair convert into pi bond into lone pair. Then what will be the contribution in resonance hybrid? The contribution of each RS will be, are the all resonating structure of equal stability? They are not of equal stability. Hello to everyone and welcome to my class. Now today we will discuss the question which I already given you as a homework in our last class, and along with we will discuss case 2 of resonance, how to draw different type of resonating structures. Got it? You have to draw all the structures, you have to draw with proper curved arrow. Got it? Now what is the answer of this? How many resonating structure will form for this? This is X and this is Y. What is X and Y? X and Y are number of resonating structures. The answer of X is 7 RS and Y is 6 RS. If your answer is less than 7, then pause the video and find out which structure are missing. Similarly, if your answer is greater than 6 or less than 6, then you have to recheck your problem again, recheck your resonating structures. Now, how we will draw 7 RS? Let's start with one of the, you can draw pi bond in this ring as per your what you say, as per your whatever you want to. Either you want pi bond here, you want pi bond here, because I already explained you the total number of RS will remain same. So let's start. I will place pi bond here. Now the pi bond conjugation with positive charge. So this is our first RS. This is the movement of pi bond. There will be positive charge here. Then again I will move this pi bond. Then positive charge will come here. Again I will move this pi bond. Positive charge will come here. Again, if I move this double bond conjugation with positive charge will come here. Now again I will move this pi bond, then this is the positive charge, come here. Got it? If I move this pi bond, then positive charge come here. Now what about this first and last RS? Are they identical? They are not identical, because due to change in position of this pi bond. So how many resonating structures will form? There will be a total 7 RS. You have to remember this problem. I will explain in the further lecture what is the significance of this. You have to remember. What you have to remember? This is the structure of naphthalene. In naphthalene we have two type of positions are there, two type of carbon. It is alpha carbon and next one is our beta carbon. If carbocation is here, then we call it beta. If carbocation is here, we call it alpha. Got it? So if carbocation at beta position, there will be a 7 RS. So you have to write in your class notes. If carbocation formed at beta position of naphthalene, although it is not naphthalene, just to remember, if carbocation at beta position of naphthalene, there will be a 7 RS. Similarly, in this example, there will be a 6 RS. If carbocation at alpha position of naphthalene, there is a 7 RS. So first of all, double bond conjugation with positive charge. If I move pi bond here, the positive charge will come on this carbon. Got it? This means this is extra pi bond. Now what is the second RS? Then I will move this pi bond here, then I will get this positive charge. If I move this pi bond here, positive charge. Similarly, if I move this pi bond here, positive charge will come on this carbon. And this is the last RS. Now, this carbocation is under cross conjugation. What is the meaning of cross? It can undergo resonance from left hand pi bond as well as resonance from right hand side pi bond. So what you have to do, you have to draw resonating structure across left hand pi bond, double bond conjugation with positive charge, and you have to draw pi bond conjugation with positive charge of right hand pi bond. If I move left hand pi bond, this RS will form. If I move this right hand side pi bond, this RS will form. Are they identical? They are not identical. Similarly, the first one and last one RS is identical. They are not identical because of change in position of pi bond. So how many resonating structure will form? 6 RS. So what you have to remember? You have to remember if carbocation formed at alpha position of naphthalene, there will be a 6 RS. If carbocation formed at beta position of naphthalene, there will be a 7 RS. This is the point to remember. You have to remember. Now let's start with case 2. What is the case 1? In case 1, double bond conjugation with positive charge. Now in case 2, when double bond is in conjugation with lone pair or negative charge. So first of all, write down in your notes, case 2, double bond in conjugation with lone pair or pi electron. Double bond conjugation with lone pair or pi electron. You should always try to form a bond. Bond formation is always favorable because whenever bond formation, energy will be released, stability will increase. So try to form new bond first. Don't try to break bond. Just like in our relation, we always try to maintain or make new relation. We never try to break a relations. So similarly in molecules, you have to try formation of bond, just like formation of good relations. Now, let's start with first example, double bond conjugation with lone pair. So what we have to do, we will move this lone pair into pi bond and pi bond into lone pair. Lone pair to pi bond into lone pair. So this is double bond conjugation with negative charge. So this negative charge will move from this oxygen to this oxygen. Got it? And what is the stability of these RS? They are exactly same, they are duplicate, or you can say they are judwa. So they are duplicate means 50% contribution, 50% contribution. So what is the charge in resonance hybrid? Resonance hybrid has minus half charge, minus half charge. Got it? So draw these two resonating structure along with resonance hybrid. What you have to do? You have to move lone pair then pi bond. In today's lecture, mainly what we will do, we will move lone pair then pi bond. Lone pair convert into pi bond convert into lone pair. Now let us now try these examples, second, third, fourth. You have to draw number of RS, then you have to draw resonance hybrid. What you have to do? You have to move lone pair into pi bond and pi bond into lone pair. Pause the video and try all these 3 examples. Now let's discuss the answer. In this example, this lone pair convert into pi bond into lone pair. So these two RS, are these two RS of equal stability? Yes, they are equal stability. Then what is the resonance hybrid? What is the resonance hybrid? The resonance hybrid will be nitrogen, carbon, nitrogen, double bond character. And since these two RS of equal stability, so what is the contribution? 50% and 50%. So there will be a minus half charge on nitrogen. This is the hybrid for the example number 2. Similarly, in this example, the pi bond will be in between these carbon oxygen. In this RS, pi bond will be between in these two carbon and oxygen, and in this RS, pi bond between carbon and oxygen. So how to draw RS? Double bond conjugation with lone pair. Convert lone pair to pi bond and pi bond to lone pair. Then again convert lone pair to pi bond and pi bond to lone pair. So there are 3 RS of this carbonate, all RS of equal stability because they are similar, they are exactly same. So how many contribution in hybrid? 1 by 3. 1 by 3. 3 RS of equal stability. Can you draw hybrid? Yes, hybrid. What is the net charge on this resonating structure? Net charge is -2. This means -2 charge is equally delocalized among 3 carbon. So this means that in resonance hybrid, there will be a -2/3 charge. So let me explain how -2/3 charge. Let us consider this RS. The contribution is 1/3, oxygen is neutral. So how many charge it is contributed in hybrid? This oxygen is contributing 0 charge in hybrid. Similarly, the contribution of this RS is 1/3. This means this oxygen contributing 1/3 charge. Similarly, this contribution is also 1/3. This means hybrid must have -2/3. Got it? Means -2 charge is equally delocalized among 3 oxygen. Similarly, in fourth, the lone pair convert into pi bond convert into lone pair. This positive charge is not delocalized, it is a localized. The resonance takes place between lone pair conjugation with pi bond. So we have to convert lone pair to pi bond and pi bond to lone pair. This structure will form. Then again lone pair to pi bond to lone pair. Now 3 RS of equal stability. Can you draw resonance hybrid? Yes, we can draw resonance hybrid. This nitrogen has complete positive charge, then -2/3, -2/3 and -2/3. 3 RS of equal stability. And nitrogen must have complete charge because this nitrogen positive charge is localized. Draw all resonance hybrid in your class notes. If you feel that I am teaching fast, then you have to pause the video. If you feel that I am teaching slow, then you can increase the speed of the video. Now try this. In example 5th, there will be a 4 RS, the double bond conjugation with positive charge. For better understanding, I will number the carbon 1, 2, 3 and 4. The pi bond in between 1 and 2. The resonance lone pair and pi bond conjugation, lone pair convert into pi bond convert into lone pair. This means pi bond will move from 1, 2 to 2, 3 carbon. Again this lone pair convert into pi bond convert into lone pair because double bond conjugation with lone pair. This means the pi bond will move toward 3, 4. Again lone pair convert into pi bond convert into lone pair. This means this pi bond will move toward 1, 4. How many RS will form? 4 RS. All 4 RS have equal stability. So what is the contribution in resonance hybrid? They all contribute 25%, means 1/4 contribution. So can we draw hybrid? Yes, we can draw hybrid. What is the net charge on resonating structure? Net charge is -2. This means -2 is equally delocalized among 4 carbon. So this means each carbon will carry -half. How -half? The contribution of this third carbon is 1/4, means -1/4 charge. This is neutral and -1/4. -1/4 and -1/4 means -half. Got it? Similarly, example 5th, there will be a 5 RS. 6th is important example. So first of all, this lone pair convert into pi bond and pi bond convert into lone pair because double bond conjugation with lone pair. This means this negative charge will move toward from carbon number 1 to it will go to carbon number 4. Then again lone pair convert into pi bond convert into lone pair. This means the negative charge will be on second carbon. Again lone pair convert into pi bond to lone pair. This means the negative charge will be on fifth carbon. Again this lone pair convert into pi bond to lone pair. This means negative charge will be on third carbon. Third carbon, fifth carbon, second carbon, fourth carbon, 1 carbon. So how many RS will form? 5 RS of equal stability. Then what will be the contribution in resonance hybrid? The contribution of each RS will be 1/5. Then what would be the resonance hybrid? In resonance hybrid, minus 1 by 5 charge on each carbon. Means net charge is minus 1 and minus 1 is delocalized among 5 carbon. Minus 1 is delocalized among 5 carbon. So each carbon will carry minus 1 by 5 charge. Now in example 7, it is a phenoxide ion. How many RS of phenoxide are there? 5 RS. The double bond conjugation with lone pair. Lone pair convert into pi bond convert into lone pair. This means negative charge move toward ortho. Again lone pair and pi bond. Again this lone pair to pi bond and pi bond to lone pair. Again this lone pair to pi bond and pi bond to lone pair. And this structure, last and first are different because of change in position of pi bond. In this case, the pi bond is nearer to the oxygen, and in this case, this pi bond is away from the oxygen. Or we can say change in position of pi bond. And what is the resonance hybrid? Are the all resonating structure of equal stability? They are not of equal stability, because in some RS negative charge on oxygen, in some RS negative charge on carbon. This means the resonating structure of different stability. Now, if RS is of different stability, then how to draw hybrid? Delta minus, delta minus, delta minus, delta minus. This is the resonance hybrid. Now, we cannot write exact charge. When we will write exact charge? When the RS are of equal stability. Got it? Now, try this. This is the answer. Now lone pair convert into pi bond convert into lone pair. This RS will form. If lone pair convert into pi bond, nitrogen has positive charge and carbon has negative charge. This means two RS of different stability. Then what is the resonance hybrid? There will be a positive charge on nitrogen and negative charge on carbon. This is the resonance hybrid. Similarly, in example 9, this lone pair convert into pi bond to lone pair. Then what is the resonance hybrid? Double bond, delta plus and delta minus. This is the hybrid. In 10th, again lone pair convert into pi bond to lone pair. Then what is the resonance hybrid? Chlorine has positive charge and carbon has negative charge. Similarly, in example 11th, this lone pair convert into pi bond to lone pair. This will form. Then what is the resonance hybrid? Negative charge will be shared among carbon and oxygen. This is the resonance hybrid. Got it? Now try these examples. Pause the video and try examples. Now these are the answer. Hopefully all will be correct. Now in this case we will delocalize lone pair to pi bond. So negative charge will be at ortho position on this carbon, then this carbon and this carbon, and positive charge will be shared by oxygen. So this is the resonance hybrid. How many RS will form? 5 RS. The structure of 12th and 13 are similar. In this case, lone pair of nitrogen are delocalized. There will be negative charge on this ortho position. This is meta, this is para. This is ortho, this is meta. So ortho, para and ortho. What are the ortho meta position? They are with respect to any group. If there is a hydrogen of benzene is replaced by group, the carbon adjacent to this group is known as ortho position. Next is meta, next is para. Similarly, this is ortho, this is meta. In mono-substituted phenyl ring, how many ortho positions are there? 2 ortho positions. O for ortho, M for meta, P for para. So in mono-substituted phenyl ring, there will be a 2 ortho, 2 meta and 1 para. Now in this case, the lone pair delocalize, lone pair of oxygen and pi bond will delocalize. So this will be the resonance hybrid. How many RS will form? 2 RS. Got it? Now I will give you some example as a homework. What you have to do? You have to draw all the resonating structure, then you have to draw hybrid, and you will start drawing by lone pair to pi bond and pi bond to lone pair. Got it? First convert lone pair to pi bond and try to form bond first. Don't try to break bond. Try to make relation, don't try to break relation. Now write down these all examples. I will discuss the answer of all these examples in our next class. Got it? These 31 examples are your homework. You have to try all these 31 examples before watching next lecture. As I already told you that all my courses are free on YouTube. I am sharing exactly the same content whatever I am teaching in the quota. You will getting all the free content through YouTube. So what you have to do, you have to follow sincerely. If you want to learn proper subject, you have to draw. Don't simply watch. You have to draw all the structure. Whatever I am saying, please follow it, then you will be good in your subject. And once your subject will be good, then you can score high in your competitive exam or you can score high in your board exam. And don't try, and please subscribe and share my channel with other students and other friends. Thank you. Jai Hind. We will meet in next lecture.